Hello. Hi. Hi, Divya. Okay, so welcome to the stream. We are in Java streams, part 6, and this is level 3, question 6 to 10. We'll be looking at today. You can see it on the notes on the side. Okay, so we are back to the stream after 2-3 days. I guess I was out of station and I couldn't stream the past 2 days. So we'll be continuing and we'll be doing streams every day, night as usual. I do not have any plans in this week. So yeah, we should be available. I put the stream for 7 o'clock, scheduled it for 7 o'clock, but I started early because I finished preparing. So meanwhile, we'll just quickly go through a recap of what we did for the first 5 questions, okay? Just to refresh our memory. Is that fine? And are you able to, able to hear me? Everything is fine, right? My screen, share all of it. Okay. Okay, so let's go then. So given a yes, okay, thank you. So we'll look at the first 5 questions of the L3 assignment itself, the level 3 assignment. So the first question was given a list of employee objects where each employee has a name, department, salary. Write a method that returns a map where the keys are department names and the values are average salary of employees in the department. Okay, so they gave a list of some employees and they need a map where the key is the department name. So you have to like group by the department name, and then the value in each of it should be the average of each. Average, is it average or some? Yeah, average salary of the employees in that department. So how did we do it? We did a grouping by collector, and then the key part was the department name, and on the value part we had to first of all get the list of all the employees in that department, and for each of that list we get the salary, map the salary and average it. If we do not have any salary for any employees in that department, we simply return 0. Okay, so that was that. For the second question, from a list of employee salaries, find the second highest unique salary. So they gave simply a list of integer salaries. They didn't even give like a list of employees or anything. Just the salaries are there. We are supposed to sort it in reverse order so that we get the descending order of sorting, so that the highest salary comes on top. And then we did distinct to get the unique values in that, and then we skip 1. So why 1? Because it's always second highest means you skip only 1 so that you get the second item. If you skip 2, you get the third highest. Okay, so this is actually n-1 always, n-1. okay, and then it's actually skip -1. How much ever you want to skip, that -1, and then find the first element in it, and if there is no element, you return -1. Okay, so that's what the question also asks. If there is no second highest unique salary, return -1. Fine, so that was second question. And the third question was transform a list of strings into a map where the key is the string and the value is its length. So they gave a list of strings with fruits in it, and for each fruit we were supposed to calculate the length of that fruit name and return that as the value. Okay, so the key value, the key part is the name of the fruit itself, and the value is the length of each string. So what we did the simple collectors.to map where key part is the string itself, whatever we got in the string array, and the value part is the length of the string. Okay, this is a simple question. Fine, moving on to fourth question. Given 2 lists, find elements that appear in both lists. So they gave 2 lists and we were supposed to find things that appear in both lists. So 1 is appearing only in first list, so we don't care. 2 is appearing in first list only, we don't care. 3 and 4 are appearing in both lists, if you see here, and 5 and let me make it bigger. So 5 and 6 are appearing only in the second list, so we do not care, we ignore it. Okay, so the final output will be 3, 4. And for that, what we did, we started a stream on list 1, And for each item, each value 1, we are again starting a stream on list 2 and checking if at least one match we get. So any match we checked, if at least one item of value 1 is there, if the value 1 is present at least once in list 2, then we filter it in. So the filter function is there, right? And finally we get all the items that match the filter and convert it into a list and return it. Okay, so return a list of integers that match that filter. And for the fifth question, split a list of integers into even and odd numbers using partitioning. So here we are supposed to do the partitioning by collector, in which the value will be either true or false. So the key will be either true or false. So it will give us a map of boolean comma list of integer. This is where we even understood the difference between this partition by, it takes a predicate. So predicates always return boolean, but if you see grouping by, it takes a function, right? It takes a function. So function can return anything, not just boolean values. So just a reminder about that. So I'll comment this out. So why we did this grouping by is, we can do this by grouping by also, or partitioning by, but partitioning by out of the box gives a boolean output. So we don't need to go for grouping by. Grouping by, we have to write some extra code to do that, right? Like this, the key part we have to write specifically, and then the value part also. But then in partition by, the key part is by default true or false only, because it's boolean, and we have to just redefine the value part, or like the partitioning formula. Okay, so the partitioning formula is, if value mod 2 equal to 0, that is, if value is divisible by 2, then that becomes true and goes to one part, which is the true part. If it is not, it goes to the false part. So whatever is in the false part are odd values, and whatever is in the true part are even values. Okay, so that was the recap of the first 5 questions. We have 4 more minutes. If you guys have any questions or doubts on the first 4 questions, first 5 questions, we can discuss that. Else we'll move to the 6th question, right? We'll start with the 6th question, which is the first question today. Let's start. Okay, fine, then let's start with the 6th question. So this is the first question in today's stream. The question is, from a list of strings, find the n most frequently occurring elements. Example, input is apple, banana, again apple, orange, banana, apple, and output is apple, banana. But in input they also gave n equal to 2. Okay, so let's go to our drawing pad. I'll explain the question. Or okay, wait, you guys first read the question and see if you can understand it. Once you guys understood the question, or like once you guys have finished reading the question, we'll go to the drawing pad. Understood? Okay, so let's move on with the whiteboard explanation. Okay, so they have given, let me take a different color. They have given this list, right, of apple, banana, apple, banana, apple, orange, banana, apple. Okay, now they're asking us to find the top n frequently occurring item. Okay, so first of all, let's count how much apples are there. So apple, right? Apple is there 1, 2, 3 times. Okay, banana is there 1, 2 times, and orange is there 1 times. Can you take a better example with conflicts? Yes, I'll go to that next. Okay, fine. So now we have apple, banana, and orange, each coming 3, 2, 1. Okay, so now they asked top n items. So what will be the answer of this? So they want the top 2 frequently items. Okay, so this is the first position, this is the second position, this is the third position. Okay, so they want only these 2 items, the top 2, which is apple and banana. Okay, and in that order is what they usually expect, because apple came first. So when you construct a list and you are returning it, they want a list of strings. So the apple and banana should be the output. Okay, that is what they expect. Fine, so that must be clear. Now the next question, next thing which we can see is something with more conflicts. So for example, maybe apple is occurring thrice, banana is also occurring thrice, orange is also occurring thrice. So when you say top two items, what should be the output? Okay, so let's see that. Let me add some space here. Okay, so let's take an example of the same thing, but then I'll add one more banana, okay, and one more orange. Okay, so now there can be a conflict because I'll erase this other stuff. So I should have, I'll erase these values, okay, and the output I'll erase. So now let's see. Okay, apple is there thrice, banana is there thrice, orange is now it's there only twice. I'll make it thrice. 1 second. So I'll add one more orange. Okay, orange. So in the end there is 1 2 3 oranges, 1 2 3 bananas. Okay, now each item is there thrice, alphabetic order ascending, so apple, banana. But I didn't understand. So you are saying that could be the solution, that you sorted by alphabetical order. The answer. Okay. That might be fine. That could be one way of resolving the conflict. And that would be the right answer in this case also, because they are alphabetically sorted anyway. But let's do this. I'll remove this last orange from here, okay, in the end, and I'll put that orange in the beginning. Okay, so this list starts with orange, okay, and ends with this banana. Now what do you think is the expected answer? Okay, this is like one more level of complexity, more than the conflict. AB, apple, banana. Okay, so if you were sorting alphabetically, that is correct. But thing here is, this question didn't mention, what kind of merge conflict they want. But if you see the answer they gave, or like the test case they gave, in here they have added a lot of fruits here, right? Apple, banana, apple, banana. So you see a lot of fruits here. They expect banana, pineapple. So what they are expecting is whatever element came first should be the merge conflict. Okay, so this is not an answer or something that I'm giving you. So yeah, first same element with max frequency we have to find. Correct. So what they are expecting is orange is the first item that came, that was seen. So let's say I build an output, kind of tree, or like some data structure for the output. In that case, the first item that I see, even when I'm going through these items, right? So orange will be the first item that I see, and I'll count like 1, and then apple is 1. Then I count banana 1. Then I see again another apple, so it becomes +1. And I see again another orange, +1. Orange +1. Banana becomes +1, and apple becomes +1. Finally, banana becomes +1. Right? So now when I do top 2, I should get these two, orange, apple. Right? I shouldn't be getting apple, banana like in alphabetical order. That could be one way to solve the conflict, but then this question expects this to be like this. Okay, so now that the question is fully clear, if you guys have any other questions also, let me know. But now that this is fully clear, how would you solve it? Okay, what strategy would you use? We have to find out the frequency of each item, correct? So how will we find out the frequency? Okay, so there are two solutions to this. One is the very naive and kind of dumb solution where you use the collections dot frequency, this function where you can give the list and then the string that you're looking for and then figure out the frequency, right? That is one naive solution. Another solution is to go through the better solution. So why this is naive is because for every item in the list you have to again go through everything, right? So let's say I do collection dot frequency. Let me erase all this. How do I select all of it? Okay, so let's go back here. So if I do okay, so if I do frequency, the collection dot frequency function, what it will do is it will take two arguments. One is the list itself, okay, that is argument one, and next is the lookup term. For each item you have to do run collection dot frequency. Yeah, I mean that is the naive solution. So as you can already expect, or as you can already see, the problem with this is for each lookup, let's say I want to see count the frequency of orange. What it will do is it will look through the whole list and see how many oranges are there, and it will return 3. Now I want to see what is the count of apple. It will again go through the whole list and find how many are there. Then it will again say 3. Then it will look for banana. It will go through the whole list. Now let's say there are like million items in our list. You can see how much computation this will do, right? So when I go to this apple again, it will again go from the beginning of the list. It will start from the beginning of the list. From orange it will start, okay, and it will look orange is orange, and apple, no, is apple and apple, yes, 1. So it will count. Banana is not there, apple 1. Again till the end it will go, you see one more apple is there, and then it will end with this side. So you'll get 3 apples here. So for each item you are doing this. This is very it's a very bad solution because this is a big of n square solution. So for every element, for each element we have iterating through the whole list, so becomes a very bad n square solution. We can try that solution because we are trying to solve it just with streams, with a single stream, but as you can already see, it's very bad. What we can do is we'll do it with double streams. So this is kind of the first solution where we have to use 2 streams. Okay, so what we can do, we can first of all build a map kind of data structure. Okay, so what the map kind of data structure will do is it will have apple 3 times, banana 3 times, orange 3 times. So the key will be string, okay, and the value will be an integer or long, whatever the count. Okay, so this will be our first data structure that we build. Okay, now after we get this data structure, we will again do a stream on this data structure to understand what is like the topmost occurring element. Okay, so let's build this data structure first to just identify for each item what is the count of that item in the list. Okay, so how can we do that? Any ideas? Sorry, can you come again? So we'll do this in 2 steps, okay, because we if we see that one shot is always causing problem, as in the big of n square solution, we'll do it in 2 shots. in one iteration, what we'll do is we'll build a, a safe list for us, or a safe map for us, which says the key is the value itself, like the item which you are looking for, and the value will be the count of that item. Okay, so it's like apple came thrice, banana came thrice, orange came thrice. So we are going to build a map of string comma integer. Okay, so that is the question. So how will I build a map of string comma integer out of this list of strings? So in the question, if you see, they gave a list of strings, which is like the list of items, like apples or whatever it is. I mean the fruits, list of fruits. From this list of fruits, how will I build a, so I'll write it here, map of string comma integer. I think it will be long when you count it, of map. Okay, something. How do I build this? So instead of null, what should I write here? So in this, the key will be the fruit itself, and value will be the frequency of the fruit. Okay, I can only think of collection dot frequency on each item. Okay, so that is fine. That is one good solution. But then we also have in stream specific a different solution. Okay, so let's do that. So in stream, let me open strings dot stream dot collect, and then you have the grouping by collector, right? Collectors dot grouping by, and I am going to group by the name of the fruits itself. So I do for every str, I do str. Okay, then I do comma, and then collectors dot counting. Okay, I hope this is correct. I don't know what is wrong. I think the counting should be inside this. Yeah. Okay. Yes, we can use function identity. I just wrote it like this so that everyone understands. So I'll just write function dot identity. Okay, so what is happening here is, let me write it neatly. This is the key and this is the value. Okay, okay, so is this understandable now? So till now what we understood, what we have done is we just built a simple map in which, it becomes like apple. So for this example that they have given, apple is there 2 times. Okay, then you have orange how many times? 1 time. And then you have banana how many times? 2 times. Okay, you got a hash map which has these values. Okay, till now we have constructed this. Now comes the little bit complicated part. Okay, where you have to find the n most frequently occurring elements. Okay, so for that what we can do is, let me draw that here. I need more space. Just a minute. Okay, fine. So we got this. Let me erase these parts. Okay, erase this also. And we have our apple 3 times, banana 2 times, and orange 1 time. Okay, so this is our current example. Now what we can do is we create a stream on this entry set. So map has entries, right? So entry set is a data structure of key value pair. Okay, this is the entry set, map.entry. Okay, this is actually a collections thing, Java's collection API, not streams API strictly. So in Java collection, there is this thing called entry set. I mean entry for every map. So each key value pair is called an entry in a map. Okay, so you create a stream over the entry set. So any map, when you do map dot, you get a getter called entry set, which will give you the list of all the entries in it. You create a stream on it. Okay, Now, when you create a stream on it, you can first of all do a what is a sort, okay? And what will you sort on? You can sort on the values, okay? Because as you know, this is the key, this is the value, okay? We are what is say more interested in sorting by the values. So 3 to 1, these values we want to sort in what is say descending order, okay? So you sort by values, fine. Now once you sort by values, you will have the entry set sorted like this in whatever order it is showing. Now you will get it sorted. What should you do next? They ask top n items, right? So let's say like top what do they ask? N equal to 2, right? You need the top 2 items. So what can you do? You have the limit function for that to get like the top x elements, n elements. So in the limit you pass n, so you will get limit should be n itself, not n minus 1. Skip should be n minus 1, because if you say limit to 2 items, then you get 1 item, 2 item, it will limit here, it will not bring the third item. Okay, got it, fine. Let me undo that. Okay, so you limit it to n items, and then what do you need? The output is actually asking the list of strings. So if you see, it's just asking the list of fruits. So what you have to do is you just map each entry set to its key, because key is the fruit name, right? So you have to map the entry to its own key, and then you have to do a to list, so that you get a list of fruits. Okay, I'm pretty sure it's very complicated and confusing. Is there should I like re-explain any part? I want to see how values can be sorted. Right. So good question, because we haven't seen that till now in streams per se, but that is a concept of collection. So yes, that's a valid question. We will look into that. Okay. So I'll start writing. So what we'll do is this map we have, right? So we'll call this interim map. Okay. It's a map which it's like a helper map for us. So map dot entry set. Okay, so this is the what I said. So this entry set, it gives a set of key value pair. So for us, the key is a string data type and value is long data type. So we got a set of entry of key value pair. Okay, on this we'll start a stream. Okay, and on this stream, what is the first thing we did? We did a sort on values, right? So how to do that? So dot sorted, and in this sorted we have to give a comparator. So I have to say to it that you have to compare by the value of each entry, right? So what I'll say is I'll take entry here and then say comparator dot comparing comparator dot compare. I can't take that value itself, right? Because comparing takes a method reference, so I should use that itself directly. Okay, so I'll say comparing. What should you compare? Entry dot comparing by value. Okay, I made one small mistake here. So what I did is I'll show here. So I wrote comparator dot comparing and then entry dot comparing by value, right? So I'll just go into the definition of comparing by value. Okay, I'll control click here. You see comparing by value already gives a comparator. Okay, so I don't need to again say comparator dot comparing. Okay, so I can simply go back here and change this to like this, entry dot comparing by value. That's it. Now in comparing by value, I'll say comparator dot reverse order. So why this is? Because I have to say that it should be in descending order, right? So with this, just read this once, because this is the first time we are seeing this collection API thing. Okay, so let me write it neatly. Okay. Yeah, we have to collect. I'm just showing this part. So you sorted it, and uh, sorted by the value of each item, not the key part, because value is what shows the numbers, right? Like 3 to 1, this part, right? The 3 to 1. Okay. So we sorted, and then what we do, dot. We can't directly collect also. As you can see, you have to get only the list of strings. So you have to map that. So you have to map first, to map it to entry dot sorry so it should be map dot entry, okay, dot colon key, get key. Okay, so with this you will get the keys, and then you do dot to list. Okay, that's the collector we need. Okay, so with this you will get a let me do that, list of string, which is the result we want. Now let me return this. Okay, limit, yes, I missed limit. So before map I need to dot limit it to n. Okay, good. So what else is left? Sort, limit, map to list, everything is done, right? So sorted, limited to n number of items, okay, and then map. Okay, all well. Now let's see what this will give us. Let me open call hierarchy and run this. Okay, join it. Okay, and it failed. Now everything we wrote is kind of fine, but we missed one important part. Can you guess what? Order, yes, exactly. So as we saw in the beginning, here app, let's just do a simple exercise to see how many times here it is coming. Okay, I'm just writing in my iPad here. So apple is there, 1 2 3, what is the next? That's it, 3 times. Okay, banana is there, 1 2 3 4 5 times. Just count with me. If I'm wrong, tell me. Apple came again. Orange is there, 1 only once. Okay, 1. Then you have kiwi came 1 2 3 4 times. Okay, 4. Then you have banana again, pineapple, kiwi 4, right? Yeah, pineapple 1 2 3 4 5 6 pineapples. Okay, and grape 1 2 3 4 5 6 7, 3 6 7 times. Okay, am I right? 1 2 3 4 5 6 7. Okay, 7 times. Okay, so I hope I counted everything correctly. Okay, so if you see here, this is what it came. Then I counted something wrong, because there should be a conflict. Only then the problem will come. Something should have come 7 times one more, or 6 times one more. Let me recount. So pineapple, 1 2 3 4 5 6 pineapples. Okay, and banana 1 2 3 4 banana, 4 bananas only. 5 bananas. Are there 5 bananas? 1 2 3 4. Oh yeah, 5 bananas. Yeah, 5 bananas, correct. So they said banana and apple are the topmost, right? banana and pineapple. But then how come grapes is there 7 times? 1, 2, 3, 4, 5, 6, 7. So it should be grape and pineapple, right? That should be the answer, right? It's wrong maybe. Yeah, this thing itself is wrong. Okay, so let's do one thing. So according to the test case is wrong. First of all, it said, what did it say? It expected banana, pineapple. Okay, it expected this as the answer, but that can never happen because the topmost, if you see, is grape and pineapple. So that should have been the answer. Can you show the output? Yeah. So it said it expected banana, pineapple, but we got grape, pineapple, which is correct because according to our rough draft, that is what is coming also. See, grape is coming 7 times and pineapple is coming 6 times. So we are right. Yeah, we are right. But the thing is, I want to do a conflict. Okay, so let's say I said pineapple comes 5 times. Okay, I'll make this 5 times. Now banana is also there 5 times, pineapple is also there 5 times. Okay, how do I make sure that banana comes first? Okay, because banana is the thing that appeared first in the list, right? So what will I do? Banana, I should add one more banana, is it? Right, so no, 1, 2, 3, 4, 5. 5 bananas. Oh, I should remove one pineapple. Okay, I'll remove this pineapple. Okay, I removed this pineapple. Now let's run it and see. We got banana, pineapple. Correct. But it is expecting correctly only. Hey, wait a minute. What did we get? Oh, but was grape, banana. How did grape come? Grape, banana. We have to modify the compare to compare the key when values match. Yes, correct. So I'm just checking, making sure that the test case is fine. So it is expecting, yeah, it should expect pineapple. It's just the order. Okay, so pineapple, banana. This is what it should expect, right? But we got, sorry, you should expect grape, banana. Okay, it passed already because that's what is coming, okay. So grape is 7, so that should be first, and then out of these two, banana is the first thing that comes, so it should come like G and B, grapes and banana, which is what it should expect grape, pineapple. No, it shouldn't, because pineapple is coming later. Okay, let's do one thing. Let's put pineapple first. Okay, let me remove this banana here and instead make it a pineapple. Okay, so the first item that appeared is pineapple. Let's see what happens now. So it should expect grape and pineapple, right? Run it. It's working that way only. So it's already coming in the order of appearance. So we need not do anything extra. Okay. Should we do like an interesting exercise and do the reverse, sorry. As in whatever comes later in the order should be appearing first. Should we try that? Yes, okay. Okay. I see you are very adventurous. Fine. So let's do that. So what we are going to do is, let me reset this back to how it was so that it is easier for me. Okay. Okay, now it should expect pineapple. No, banana only. Correct. Banana. No, sorry, pineapple. Right. Okay, so I fix the test case. Test case is fine. Now I'll go to the whiteboard again. Okay, so I'll erase this stuff. Okay, so it should now sort this, right? Sort this by how many times each items appear. So it should be grape 7. Okay, now there is nothing with 6 items, but 5 items there are 2, right? This is also there 5 times, this is also there 5 times. But I want to sort it based on which appeared last. Okay, so pineapple should come first because pineapple came down here, right? So I'll say pineapple came 5 times and banana came 5 times. Okay, so I sorted it based on what came last. Now what will I do is, so the remaining is as it is. So you see apple, orange, kiwi, that will come next. So kiwi 4, okay, and what is that? Apple 3 and orange once. Okay, we don't care about these 3 items because we need only the top 2 items, right? So this is the expected answer for me. Now how do I bring this? Okay, so for that we have to compare the index of the item, right? So where that item appears in the list. Now how can I do that? In this comparator, you know, there is this thing called comparator dot comparing. Then you also say then comparing, right? So you can chain multiple comparing, saying this is the first priority comparison. When there is a conflict, do you do a dot then comparing to say the how do you resolve that conflict, right? I hope, yes, index of fruit, correct. Okay, so that is how you do the then comparing. Now let's see how to do that. So first of all, this will be of no use. We have to do normal comparator dot comparing. Okay, and you compare what? Map dot entry colon value, right? Get value. So this is the first level of comparison where you have to sort by the number of items. So you have achieved this. You have sorted by the number of items, like 7 is it? Yeah, 7 5 5 4 3 1. So you sorted like this. Now you have to say 5 and 5, there's a conflict. How do I sort it? Okay, I'll come to reverse order. There is reverse order, I forgot that. Dot reverse order? No, I have to say it inside this itself. So comparator dot reverse order. Okay, so we sorted it in reverse order also, fine. So descending order is also done. Now comes the interesting part where we say okay, I'll come and add this dot then comparing. So in then comparing is what we have to say what is the next one. Okay, now we have to see the index, right? So for each entry, so we get an entry here, right? You have to see where is this guy, the in first result strings we got. Okay, strings dot index of entry dot get key. Okay, this is what is happening to this. I think you have to, okay, let me remove this also. So how do I write the dot then compare? Dot then comparing, yeah, there is a function here, right? So I can write a function. Strings, reverse order strings. Okay, I want to write a function here, like for each entry. Hey, yeah, strings dot index of, yeah, pass null. That will work. Sorry, null. No, that also didn't work. As you already know, the what do you say, Eclipse IDE doesn't accept it unless you give the full, solution. Hey, why is this failing? Why is this failing? Did I do something else? Okay. Comparing dot then comparing. Yeah, this itself is not working, right? Let's do one thing. Let's write a function. Okay, Samsung, yeah, right outside. Correct. So private static, compare entries, position. Okay. And then what I'll say is, so private static, it should give a int, right? So into this, I'll pass the entry itself, map dot entry. Okay, and I'll pass the entry, and this k comma v will be string comma long. Okay, you got an entry, and you need the list also, the original list of strings. Okay, and then you are going to return strings dot index of entry dot get key. Okay, now how do you pass this? Yes, -1, 0 or 1, I guess. Correct. So I will copy this and pass it here. Okay, dot, then comparing. This should be a nope, that also didn't work. What are we missing? It is strings, right? Strings, yeah. Hey, this is not being called. Okay, because this didn't pass. Okay, let's do comparator. Can we pass 2 arguments to lambda? Oh, valid point. Yeah, because that will be passing entry 1 and entry 2, right? That's correct. Okay, so when entry 1 and entry 2 comes in, I have to compare entry 1 and entry 2. Okay, then I have to do is greater than 2 1, it should be like minus, not greater than. This will become entry 1, come entry 2. Okay, this should be inside a bracket. Should I return? Hey, what did I do? Nope, that also did nothing. Entry and the fruits list. In where? I didn't get it. Oh, entry and the fruits list. No, that we can't do because comparator is. Wait, let me comparator. Then comparing, right? It takes a comparing. It takes another comparator. So let's say then comparing. There is a function. It either takes a function like these, and then again a comparator. So this is what we are trying to do with the just a function. Returns a lexical comparator the function that extracts sort key, right? This default implementation behaves as if then comparing key extractor. Wait, I think is there a sorry. If I do list x, what if I do this? Okay, so in then comparing, I say map tree of string comma long dot index of nope, I give up. Let me Google it. In then comparing, how do I sort by the index of entry key in a list of string input? Okay, this is input list dot get index of e dot get key. Okay, isn't that what we tried? So for each entry, strings dot index of entry dot get key. It was get key, right? Input list dot index of e dot get key. Should it be e only? Don't say that is the issue. Comparing map dot entry get value comparator reverse order. Okay, that is correct. Dot then comparing e input list dot index of e dot get key. Strings dot index of e dot get key. Everything is correct. What is the problem? Let me do one thing. Let me copy this. Okay, and it should be strings. No dice. So is there something wrong with this part? It is inside sorted. Yes, mine is also inside sorted. So sorted ends here. This is where the sorted bracket is ending. So the whole comparator is inside that only. So let me copy this whole thing. Okay, in sorted starts here, sorted ends here. Okay, this is the whole sorted. Inside that I'll paste this. Okay, and then comparator dot comparing map dot entry get value, comparator dot reverse order, then comparing. Instead of input list I should put strings. Okay, no dice. So let's see what this is saying. The type map dot entry does not define get value of object. Let's try to do this. Oh, this was the issue. They wanted it to be types. They wanted to specify the types. Okay, so that was the whole issue. Okay, happy. So here, this is the natural order of sorting anyway. So if you run this, it will again throw an error. Hey, there's another error. What is this error? Oh, I wrote this stuff here. Let me remove this. So perplexity code is wrong also. Yeah, I think perplexity just assumed that did it say anything? They didn't say anything about specifying the types. Perplexity just wrote whatever I wrote. Because if you see, if I remove the then comparing part, even without specifying the types, it's working. So only when you do a then comparing, I think that type is mandatory. So we might as well always use the type. Then could be Eclipse issue. Yeah, could be Eclipse issue as well. I don't know. Okay, so comparator. Now comparing this, I'll just make it neater. Okay, and then you do dot then comparing that. Okay, so if I run this, let me run it. So it failed again, grape banana, because it was giving in the order of appearance, grape and then banana first. Okay, so now what we have to do is do a reverse sort. Okay, comparator dot reverse order. Okay, now what we expect should work. Hey, why did it fail again? Where did I? Okay, it should be not here. This is the whole sorted, right? So it should be here inside the then comparing. Yes. Okay. Now if I run this, yep, we passed. Eclipse time to switch to IntelliJ. No, I'm not switching to IntelliJ. Okay, we'll stay with Eclipse only. Okay, so don't be disheartened. Eclipse makes you study harder because you see now you learned something. IntelliJ you cannot learn it. Fine. So we got our answer. We will do a recap in the end. You know, for now, I think this is enough. If you guys want anything else to be clarified, just let me know. Okay. Or shall we move to the next one? How long has it been, the stream? Where's the time? 1 hour. Okay, fine. Then we'll take a break and come back. Yeah, break. Okay, so we'll take a break and come back. Let me set the timer here. Okay, fine. See you guys in 10 minutes. I'll set a 10-minute timer. Okay, thank you. Hello. Okay. Fine. So let's move on. Where were we? We finished problem 6. Oh, we just finished one problem for today. But anyway, not a big deal because the remaining problems are kind of easy only. Okay. So let's move on to problem 7, aka the second problem of the day. Okay. So the question is, okay, read the question first. Okay. And let me know, is there any prerequisite to follow this tutorial? No, there isn't. I mean, you should have watched from the first stream, part 1. That is the prerequisite. By the way, hi Noreen. Okay. So, question number 7. Given a list of lists, flatten it into a single list using flat map. Okay. So they already gave what to use, and they have given 2 lists. Okay. So we have to flatten it to a single list. Sorry, I'm late to party. It's okay. You can catch up, watch all the previous parts. Okay. So let me know once you guys have read the question. Then we'll move on to the explanation part. Okay, so we'll go to the explanation. So we have we have a list of lists. Okay, so there is one major list in which there are sublists, okay, nested lists. And the question is to simply convert it into a flat list like 1, 2, 3, 4, and 5. Okay, a single list, and return it, right? So it went from list of integer, okay, which is kind of a 2-dimensional list. So this is 2D because it has a list of list, right? We did a similar one already, I think. Yes, we did a similar one, I think, in part 2. And this is slightly different from that. This is actually a step down from that. This is not even that complicated like we saw in part 2. Okay, so list. So this should be converted into list of integer, a single list, okay, which becomes 1D. Okay, is the question easy? Is the question understandable? Hopefully. Okay, so let's go into the solution. So what we are going to do is, let me write that also. What we are going to do is, we are going to create a stream over the first list. Okay, so when we create a stream over this, the bigger list which has a list of integers, okay, what will it do? So if I create a stream, it will give me 3 streams, right? It will give me 3 more streams of each of these smaller lists. So it will be like 1, then 2, and then 3. Okay, so from each of those items, so from this and this, 3 list streams will be generated. Now what you have to do is, you have to take the stream of each of those lists and give it to the flat map function. Okay, let me create more space here. Oh, something is happening. Oh, I think I messed up something. Okay, fine. So we will get 3 streams: stream from first list, stream from next list, and stream from the third list. What you have to do is, you have to give it to the flat map function. What it will do is, it will just connect each stream to each other, together, one after another, and it will create a final single one list of integer. Okay, so that is kind of the gist of the whole thing. Okay, so if there are no more questions, we'll go to the code. So we have this list of lists, and you do a dot stream. Okay, what will this stream give? It will give like smaller lists. Okay, so let's call it smaller lists, like the nested lists. Okay, for each smaller list, it's actually smaller list. Okay, what you are doing is doing dot. Actually, sorry, I missed one part. So you get the stream and then you call flat map. Okay, flat map. Flat map will give a smaller list, and for each smaller list, you do dot stream on that. Okay, fine. So this was what I was saying. You get smaller lists out of the major stream, then you create stream out of the smaller list again, and then in the end you do dot to list. That's it. Simple. You return this. Okay, is this clear? So we got the answer already. Let me in the flat map, right? Okay, let me run it. Okay, it passed. Okay, fine. So that was that simple question. Any questions, any doubts, or shall we move to the 8th question? Okay, we'll move to the 8th question. Am I live? 1 second. Okay, so the 8th question, transform a list of numbers into their cumulative sum. Okay, so input is 1 2 3 4 and they want the output to be 1 3 6 10. So each each index is actually having the sum of all the previous numbers and itself. Okay, so we saw a similar question of this also, but in that what we saw was we did the average, I guess. Yeah, it was a running average, but in this case it's a running sum. Okay, so we can even call it running sum. Okay, so read the sum. Solution.